In this video, we're going to take a look back at 3.3, and we're going to look specifically at linear inequalities and making them when we're given a word problem and drawing conclusions from the graph that we make. So in the question that we're going to look at, you are purchasing an ice cream sundae at Fiona's. For a regular sundae, sauces cost $2 each, while all their basic toppings like sprinkles or peanuts or whatever cost $1 each. You know that you'll want at least 4 toppings, and you only have $8 to spend. How many of each type of topping can you put on your sundae? So what we're going to do here, similar to the last video, is we're going to make 2 equations, one in terms of cost and the other in terms of quantity, and then we're going to make an inequality from there. So for our cost equation, let's call the sauces X and the other toppings Y. $2 per sauce plus $1 per other topping. No matter how much we're getting of either one of those or any combination of that, the overall cost needs to be less than or equal to $8, since that's my budget. I can spend exactly $8 and I could spend less than $8. I just can't go over it. So that's the inequality that I want to use. For quantity, I know that I want at least 4 toppings, so however many sauces I get, plus the other toppings, I want that to be greater than or equal to 4. Because I could get exactly 4, more than 4, I just don't want less than 4. So from this point, you would be able to put both of these in as like a relation in your graphing calculators. I think that for these, they're pretty simple to get into slope-intercept form. We can do it in one step. So I'll show you how to do it on here. In class, we'll go over how to do it in the calculator again. For the cost equation, I'm just going to move over the 2x. So my equation is y is less than or equal to 8 minus 2x. So my y-intercept is at 0, 8. And then my slope is -2, so I'm going to go down 2 over 1. Down 2 over 1. And I want to shade below that graph, or below that line, so I'm going to shade everything underneath. For my next equation, same thing, I just got to bring the x over. So my new equation is going to say y is greater than or equal to 4 minus x. I'm in slope-intercept form now, so I can see that my y-intercept is at 0, 4 on the y-axis. My slope is -1, so I'm going to go down 1 over 1. And make my line. For this graph, I want to shade everything above it. So I'm going to shade everything over here. Here I can see that my overlap is going to happen in this little triangle area right here. So just taking a look at the overlap part, kind of differing from linear or just systems of equations. Since this is an inequality, I could have more than one option or more than one combination of toppings and sauces that I could use to fit within my budget and to get at least 4 toppings, which is what I want. In the last video, there was only one point of intersection for all of those problems, therefore there was only one solution. Here, any coordinate in that highlighted region is going to work, so we're going to take a look at that here. So let's try a coordinate and see if it works out. So one coordinate in this shaded region is 1, 4. Remember that the x represents sauces, the y represents toppings. So I want to stay within my budget, $2 per sauce plus $1 for toppings. That would be $6, so I'm good to go. I'm within budget. 1 plus 4, 5 toppings. I'd be good to go there. Another example would be 2, 3. Again, $2 for sauces, $1 for other toppings. That would be $7, still within my $8 budget. 5 toppings again, I'd be good to go there. Since these inequalities are both dealing with like less than or equal to and greater than or equal to, my line's solid, which means that anything that's on the line could be considered as a solution as well. So a coordinate like 1, 6, for example, $2 per sauce, plus 6 for other toppings is $8. Since my budget is $8, I could spend up to $8, so I'd be good to go there. That would give me 7 toppings, so I'd also be good to go there. Anything in this problem would be considered a solution if it is on the line or inside of the lines in that highlighted region. The only thing that won't work is stuff that's outside of the lines. So something, for example, like 3, 3. If I tried that, $2 per sauce, 3 for other toppings would be $9, so it wouldn't work there. Even though that would give me 6 toppings, which is something that I would want, I wouldn't be within budget, so I wouldn't be able to do that.